Welcome to our IT department training session on understanding file systems. My name is Shelley Searcy, and today I'll be walking you through an essential topic that forms the foundation of how computers store, manage, and retrieve data. During our training, I will walk you through a file system's key functions, type, structure, and give a high-level overview of how a file system works. We will also look at practical examples and wrap up with a summary of key takeaways and references if you choose to explore further. What exactly is a file system? A file system is a specialized software that manages how data is stored and retrieved on a storage device, like a hard drive, solid-state drive, or even a USB stick. It's essential to the performance and reliability of a computer system because it directly impacts how fast we can access data and how much we can store. Here is an example of a file system on Mac OS. Think of it like the organizational system inside a filing cabinet. Without folders and labels, it would be impossible to locate anything efficiently. Similarly, without a file system, data would be one giant block of random bits with no structure or meaning. Speaking of structure, let's talk about the structure of a file system. It includes several key components. First is the boot block, which contains the bootstrapping code necessary to start the operating system. Next is the superblock, which holds metadata about the file system itself, such as its size and status. Then we have the inode table, which stores metadata about the individual files, including who owns them, when they were last modified, and what permissions are set. And finally, the data blocks contain the actual content of the files. Each part works together to ensure the operating system can access and manage data efficiently. Now, there are several types of file systems, each designed for specific operating systems and use cases. Let's start with FAT32, which is a file system ideal for USB drives due to its compatibility with most operating systems. However, it does have a limitation of a 4 gigabyte maximum file size limit. Moving on to NTFS, it is the default for Windows and it supports advanced features like file permissions and encryption. Next is ext.ex4, which is used on a Linux operating system because of its reliability and journaling capabilities. And then moving on to APFS is designed for Apple's newer devices because it's optimized for speed and solid state drives. And then lastly is HFS Plus and EXFAT. HFS Plus can be found on legacy Apple systems, and EXFAT is commonly used for external drives because it supports large files and works with both Windows and Mac OS. To give you a clearer picture, here are some real-world examples. Windows 10 and 11 use NTFS for internal drives because of its ability to handle large files and complex permissions. Ubuntu is a popular Linux distribution that uses ext4 by default because of its stability and journaling features. USB drives are often formatted using FAT32 or EXFAT so they can work across multiple platforms. Mac systems use APFS, especially for solid-state drives, to take advantage of faster performance and snapshot capabilities. Understanding which file system to use and when is a critical skill for IT professionals managing diverse devices and systems. How do file systems work? Let's take a look at how they work behind the scenes. So when you save a file, the file system breaks it into chunks called data blocks and stores those data blocks in available space on the disk. It then updates the inode table with information about where those blocks are located and details about each file. So when you open a file, the file system references that inode and finds the correct data blocks and resembles the file for you. Advanced techniques like buffering, caching, and journaling are also used to boost system performance and maintain data integrity, especially during system crashes or power failures. So to close out, File systems are absolutely vital to how operating systems manage, organize, and access data. From the way files are named and stored to how they're retrieved and protected, the file system plays a central role in performance, stability, and security. Each system, whether it's NTFS, ext4, or APFS, offers different features tailored to different environments. So, as an IT professional, having a solid grasp on how these systems work will help you troubleshoot storage issues, optimize performance, and make informed decisions about formatting and file management. And the last slide is our reference slide. So this slide contains content in this training that's supported by leading technical sources, such as Geeks for Geeks, Study Tonight, and Tutorials Point.